The Indian Space Research Organization is gearing up
kilometers
for GSLV NVS-1 Navic satellite launch.
Welcome to All Known Squad. Today we will be discussing a very interesting topic called Navic, which means navigation with Indian constellation. Similar to India, other countries which possess navigation technology are US, Russia, China, and European Union. All the navigation devices we use in day-to-day life make use of either GPS or GLONASS. So you may be wondering why the need to develop another navigation system by India. To understand why India needs its own navigation system, we need to go back to 2022 when Russia-Ukraine conflict broke out.
Russia has invaded Ukraine. The attack began early this morning.
Talking about the West sanction fever, its brazen and aggressive attempts to force others on how to behave, deprive them of their sovereignty, and force them into submission. There is
We can hear from Putin's words when West doesn't like something, it puts sanctions and may very well cut access to navigation. And it can turn disastrous for a big country like us. India was in a similar situation when Pakistan occupied 130 plus Indian posts during Kargil war. Due to the lack of GPS data on precisely where Pakistani posts are situated, which led to the extension of war and casualties. So Indian government clearly understood this and gave clearance to the development of own navigation system. So how does Navic system works and why is it so different from existing navigation technologies available across the globe? Let us imagine a guy whose name is X went into jungle for a camping trip. He is taking selfies and enjoying with himself. After some time, he looks lost and tries to find out where he is. In order to find his location, the satellite sends and receives the signal from his mobile. The time delay between the two signals is identified since we know the speed with which the signal travel, which is equivalent to the speed of the light, and we know how far our x is from the satellite. So we can construct a 3D sphere of radius which is equivalent to the distance of our guy x from the satellite. So this can be done similarly with two more satellites, and the point of intersection of all the three spheres is where our x is located. This method is called triangulation method, which is very popular and commonly used. When examining current navigation satellites, you will notice they are positioned in middle earth orbit with an orbital period of approximately 10 to 12 hours. In contrast, we have the option to place satellites in geostationary orbit, where the orbital period matches Earth rotation time of 24 hours, making the satellite appear stationary relative to Earth's surface. Consequently, if we only deploy 3 to 4 satellites for GPS signal coverage, over time these satellites will move to the other side of the globe, leading to signal loss. This is particularly problematic if they are placed in middle Earth orbit, where their orbital path resembles the graphics depicted. This is why countries like US, Russia, China and the European Union utilizes more than 25 satellites to ensure continuous and uninterrupted navigation signals. This is why at any given point on Earth, a minimum of 3 satellites are always available to accurately determine the location. In contrast, if we examine Navic, the Indian Regional Navigation Satellite System, it utilizes a unique configuration. Navic comprises 3 satellites placed in geostationary orbit and 4 satellites in geosynchronous orbit. This configuration is designed to ensure that all these satellites continuously focus on the Indian subcontinent at all the time. By positioning the satellites in such a manner, Navic guarantees uninterrupted and precise navigation and timing services specifically for the Indian subcontinent, offering enhanced accuracy and coverage for the users in that region. To assess the accuracy and satellite visibility of Navic, Jain University conducted a test along the route depicted on the screen. Navic exhibited superior signal strength compared to GPS. This means that users in the tested area experienced better reception and more reliable signal, which can be crucial for navigation and timing applications. Navic provided more accurate location data than GPS. This enhanced precision is valuable for various applications including navigation, surveying, mapping, and it allows for more precise positioning and satellite visibility. Unlike GPS, where satellite visibility can fluctuate with time and location, Navic demonstrated consistent and constant satellite visibility along the test route. This consistent coverage ensures the user can rely on Navic for continuous and uninterrupted navigation services.